Hi, we are the Electric Pythons, and our product is a diabetes detector.
Pre-processing and EDA. Why have we made this product? We are attempting to solve some financial issues. Did you know that per year it costs a single person around $12,500 in healthcare alone? Our model will allow an individual to check whether they are positive or negative for diabetes before they have a doctor confirm or deny their result. Data cleansing. Cleaning up our data allows us to make sure our machine learning model is the most accurate it can be. We can do this by visualizing our data in different ways to find different correlations between features and symptoms. Minimal viable product, or MVP. Our project MVP would be a website with a form that a user would fill out. The user would input their gender and 8 other possible diabetic symptoms. The results would be an output showing if they are positive or negative for diabetes. Included through our website are many great visuals, which you will see now.
Our visualizations include a histogram, bar chart, and pie chart. This histogram shows how many of each feature are included in either positive or negative class. The two different classes are shown as yes or no.
The next visualization is a bar chart showing correlation. This bar chart shows the correlation of each symptom to the class. A high correlation will help lead to accurate results in our machine learning, but if the correlation is low, it could affect the results to be false.
Another graph we used to show our data was a heat map. This heat map shows how each feature affects the other. The most important one is class. The class is the outcome of our machine learning and can show positive or negative results for diabetes. The class is compared with 16 other features to see which symptoms we want to use in our machine learning model.
Pie chart grid. The following pie charts represent the correlation between the 8 different symptoms, gender, and diabetes. The red section represented by a 1 is the percentage of people that have diabetes with the particular symptom. The dark blue section represented by a 0 is a percentage of people that don't have diabetes but do have one of the particular symptoms.
Decision trees are a non-parametric supervised learning method used for classification and regression. The model can predict the value of a target variable by learning simple rules. The more data, the more complex the decision rules and the fitter the model. The best parameters we used for decision trees were criterion and splitter. Criterion is the function to measure the quality of a split. Splitter is a strategy used to choose the split at each node. Decision trees was our best model, and these are the results.
Random forest is our second best model. Random forest uses forest classifiers that have to be fitted with 2 arrays, a sparse or dense array of X of shape and array Y of shape. The best parameters for random forest were max features and estimators. Max features is the number of features to consider when looking for the best split, and estimators is the number of trees in the forest. The results for random forest show that it's the second best model out of the 3.
Our third best model, KNN, is an algorithm that can be used to solve both classification and regression problems. It can calculate the distance between the given point and other points. It then sorts all the points by distance in increasing order. For classification, which is what our project is using, the point is classified by a vote of its neighbors and then assigned to the class most common among its k nearest neighbors. The k value controls balance between the values from overfitting to underfitting. The parameters used for KNN were N neighbors, weights, and algorithm. The best parameters for KNN were algorithm, N neighbors, and weights. And these are the results for KNN.
This table shows the results of our 3 machine learning models. Decision trees, our best one, random forests, our second one, and KNN, our third best model. Making this model had its challenges and opportunities, but with collaboration and perseverance, we were able to make use of the opportunities and disregard the challenges.
I am Zachary of the Electric Pythons.
I'm Naomi Castang of the Electric Python.
I'm Sophia Lee of the Electric Pythons.
I'm Josh with Jesiah, and I was part of the Electric Pythons.
These days, elementary school students learn English and coding at school. Tomorrow's elementary school students will learn AI. AI comes before English and coding. This is because artificial intelligence is the language and tool of the future.
This is our diabetes detector. We're going to have a live demo now. So you will choose your gender and choose whether you have the 8 different symptoms: polyuria, frequent urination, polydipsia, an increase in thirst, sudden weight loss, which is sudden weight loss, polyphagia, excessive hunger, visual blurring, not having sharp or clear vision, irritability, easily irritated, partial paresis, some muscle movements in the weekend, but still have control over the body, and alopecia, the partial or complete absence of hair from areas of the body where it is normally grown. You then press submit. And in this case, it says you do not have diabetes, but I hope you still enjoyed our project. In other cases, it would say you do have diabetes, please seek medical attention. Thank you for listening, and I hope you enjoyed our project.